Talking about you.
Yeah, hello everyone. Good afternoon, and I want to appreciate everyone that stayed on the call despite our technical error that we had to address. I had planned that this class would be a very long one and it will be detailed, but I'll try and do the best I can, and I will gain as much insights with the little time that we have. Good afternoon once again, and we started our last class, spatial data analysis with Python, where we talked about different Python tools that are used for spatial data analysis, and we kind of explore some visualization, some libraries like Folium, like Contestly for our visualization. And because of our time then, we didn't have time to do a lot of analysis. So which brings us to this part 2 of the class. And I hope that you'll be able to get as much knowledge from it. So you just have to work with me. So today we'll be doing some setting up. If you can code along, that would be great. But we can just share. Let me just share. If it's possible to just share the notebook with you. Maybe that will be after the class, if that will do. So just follow along. And if you have any questions, you can just raise it. So it will be more like an interactive session because of our time, but we'll make it fast and it will be worth our while. So in this class, we'll be exploring some data. So it has to do with health data, and I'm very sure that most of us will be interested in it. I think we used health facility data the last time, and I thought we should just continue with it. So we're going to filter and prepare our spatial data for analysis. We're going to perform all these stuffs, which are quite the normal process whenever we are doing spatial analysis. So something like network analysis, hotspot analysis, accessibility, and then we are going to also consider using clustering algorithms too for gaining and getting insights from our data, especially geospatial data that has to do with location. So the first step is to install our geospatial libraries. The normal pip install, GeoPandas. I think the last class we talked about GeoPandas, which is kind of the geospatial type of pandas. So it does everything pandas does, GeoPandas, and then it has the ability to handle geospatial data. And then we talked about Shapely, we talked about Folium, which is used for data visualization, and raster, which is used to handle raster data. And in the last class, we said geospatial data are two. We have the vector data and we have the raster data. So raster is a Python library, a useful Python library to handle raster data. We have Fiona and we have ESDA. ESDA is a spatial library that is used for a lot of spatial analysis, spatial statistics, especially in the geospatial space. So the next thing we need to do is just to import our libraries that are very essential for our spatial analysis. And then we move on to loading our data. So this data is going to be shared with us. This data is going to be shared with us alongside the code, so it will be easier to code with it. Because of our time, I think last class I told you about where we got our data, which is Grade 3 Nigeria. This is where you can download a lot of geospatial data in Nigeria. So this contains geospatial data that has LJ boundaries, which is one of the data that we'll be using in today's class, which has already been downloaded. So because of our time, so if you are new, if you didn't attend the first class, this is just to encourage you to, there's a recording on our YouTube channel, Thiessen, so that you'll be up to speed. But this is just to give us a brief recap. I would have taken my time to, for the new guys that just joined, but we just have to speed up because of our time. So this is grade 3. So let's go back and load our data. So I have it on my local PC. So I have this. So I'm just going to copy everything. But then when we are sharing this data, it will be organized in a proper way for you to run your code. So what I did was I imported some of this data that contains geospatial data. So I imported them in, okay. So there are a lot of data formats, geospatial data formats that we talked about last class. We talked about the shapefile. So as we have for tabular data, the data format is usually CSV, SLXX, and then for PowerPoint we have PPT. Likewise, you also have geospatial data formats. So we have shape. So your geospatial data format can come in form of shapefile. I mean, not shape. Shapefile can come in form of GeoJSON. It can come in form of even CSV. As one of our data that I just loaded for Earth facilities comes in CSV, and I'm also going to show you ways to convert it to a geospatial format so that it's easier to run, and then we can use GeoPandas to run it. So I've already loaded the data, so we have it in CSV. And understand that CSV is not a geospatial data format. So when we want to use it with some Python libraries that has to do with geospatial, we need to convert it to a format that is recognized by the library. So one of the things that we are going to do is that once a data, okay, let me just explain it like this. Once your data, if you have any data in CSV and it has the column latitude and longitude, you can convert that data to a geospatial data. And that's what we are doing now. So after loading the Earth facilities that contain all the Earth facilities in Nigeria and LGA boundaries that contain all the LGA boundaries in Nigeria that will be visually represented, I'm going to show you. We still need to convert this CSV to a geospatial format so that it's easier, since the end goal is to merge this data together, to join them together so that we'll be able to better analyze it. So what you need to do is just use the apply these formats, the longitude and the latitude column in the CSV, and then you create a new column called geometry. So that will be representation of it, and then you are able to create a normal geodata frame. So this is more or less like converting a data frame to a geodata frame, as long as the data frame, which is in CSV, has the longitude and latitude, something that can be encoded so that it can represent the geospatial component of that data. So now we have it in geospatial data formats. So this Earth facilities GDF, and that's why I made some adjustments. That's why I made some adjustments to the name so that it's easier to differentiate. So one of the key things that we are going to do today is we're going to focus on one state. So rather than analyzing a lot of states, why not just focus on one, analyze it, and then get better insights, understand the state of health in Gombe State. You want to understand how the location of health facilities has effect on the people in that state. And this is one of the benefits, this is one of the advantage of skills like this. You are able to understand things and get insights from a location perspective, whereby you can ask answer. You know, in normal data analysis, you can ask the questions what, why. But with geospatial data analysis, you can really answer the question where, and then you can gather a lot of insights just from that. You know where it's happening. And then you can ask, okay, what are the things that are happening that are affecting where it is happening, something like that. So we're focusing on Gombe, and we did some visualization with Gombe, and then we can see all the local government boundaries in Gombe State. So because we have the local government boundaries, it's local government boundaries that represent inside the data. We have we have representations of these visualizations in numerical format. So when we visualize it, we are able to see the geospatial representation of Gombe. Hope I'm not fast. Just to get feedback from you guys. Can I get feedback from the class? Hello, class. Are you with me?
Hello, sir. I think others will speak. Me, I'm just joining. I'm just trying to understand what is happening. Sorry.
All right. Oh, okay. I just want to ensure that I'm carrying everyone along. So what we are doing is just a brief recap. Is we are exploring geospatial analysis using Python, and we are making use of Python libraries. This is just to highlight that you can do a lot of geospatial data analysis using Python as a programming language, and we are showing examples of how to go. And the data that we are using Earth facilities. So we are trying to focus on a particular state in Nigeria so that we can understand and get insights from it. Is that clear?
Yes, sir.
Right. So because of our time, I will just continue, and I hope that maybe if it's not clear, you can get back to us on that, and then we can answer some of the questions. Thank you so much. All right, moving along. So this color, there's a color grading that represents the particular local government. And then if you see the X and Y, you can see the longitude and latitude represented by the X and Y coordinates. So you can see, so this is, this should be Yamatu Deba. This is Nafada, this is Duku. So let's move ahead. So in our data, we must remember that we have two data that we imported. We imported the local government boundaries, and then we imported, for our data, we also imported Earth facilities. So the idea now is to join those two data, because there are two data entirely, to join those two data together, such that we have the local government boundaries that represents all this visual representation, and then we also have the Earth facilities, because the Earth facilities will be represented as a point on these boundaries, so it is easier to understand rather than just having the boundaries. So when we have these two data sets together, we have a very informed knowledge about where the Earth facilities in Gombe State are, rather than just this map that just shows the local government boundaries or the boundary of each local government in Gombe State. So this is us featuring for Gombe State, and then this is just a basic information about the data. So in Gombe State, we have 897 Earth facilities, and there are 11 local governments in Gombe State. So this is some of the analysis, or just a distribution of the ownership. So based on ownership, most of the Earth facilities in Gombe State are public, and most of them are owned by the local governments. And the facility level, we have a lot of primary healthcare facilities in Gombe State, and they are actually primary health clinics followed by primary health centers. So we know that out of 897 health facilities in Gombe State, we know that majority of them are primary health centers. So that's one insight that we got from this data. So the next step is to join this. So one of the things that we need to keep in mind when we are joining, or when we are combining these two data sets, as I've explained, is to ensure that their coordinate reference system matches, such that if the CRS of a particular data does not match, is not the same as the CRS of another data or geospatial data, there's going to be conflict, and the joining won't there will be error in the joining. So this code is to ensure that both data sets have the same CRS, which is the coordinate reference system. So coordinate reference system is just how do I put it now? So it's just how a location is represented in a map. How a location is represented in a map. So if the coordinate reference system is so maybe we have coordinate reference system EPSG4326. It is very important that the data that we are merging into also has that code. So not to spend a lot of time on it. I think we addressed CRS in our last class, which is coordinate reference system. I can just look it up to understand it better. So this is all joining the health facility data, the spatial data, with the local government boundaries. And we are keeping all the facilities that are in the health facilities, and then we are merging it based on the local governments that they fall inside. So one of the things that we are going to do today is we are going to see the hotspots areas that are in Gombe State. So what does hotspots mean? Hotspots is about excuse me. Yeah, so hotspots is about knowing, identify the areas where there are significant clustering of high values. So hotspots means that, okay, which location, which local government are their primary health centers? You understand? And cold spots is like, okay, which local government are there little to no health facilities or health centers? And understanding this will actually give insights either to government or NGOs where to actually site the new primary health facilities, not just primary, the health facilities, so that they can reach more people. And it's very important because you have to do this analysis so that you don't just cite health facilities based on, oh, it should be here, it should be here. You need to take a lot of things into consideration in terms of, okay, how many people are living in this area? Do they have enough health facilities that can address their health needs? And if they don't, then we should cite it there. You know, that's just the basic use of hotspot analysis, and Python can actually help us. So it helps us identify those locations where statistically there will be a lot of clustering where facilities are, and then we call those areas hotspots. And those areas that there is nothing, like there is only one or two, we call it cold spots. And if we can recognize this, then we can know that, okay, this will help maybe governments to actually cite health facilities in the right way. So there are a lot of statistical tools that we normally use for geospatial analysis, especially for hotspot analysis, which is called kernel density estimation. It's a little bit statistical, but it's just like a way based on the probability density of a particular, of the number of facilities in that area. So this is also adding a buffer to that around the area. So whereby each health facilities, if it is represented as a point on the map, there's kind of like maybe like a 100-meter buffer around it, so that we will know that, okay, if there's an 100-meter buffer, like a round 100-meter radius around an health facilities, if there's an intersection of many or more health facilities in that area, we will know that, okay, this has a lot of spatial clustering. And if there is none, we know that, okay, this is a cold spot. So I'm going to show you some visualizations that kind of represent it. And this is just different visualizations to represent hotspots. So for example, you can see that there are a lot of hotspots in this area, while in some areas we know that there are a lot of cold spots. You can see based on that area. So you can see that, okay, in this particular location, Based on this location, we can say that, okay, this area has cold spots and this area has hot spots. Okay, where should we site the nearest earth facility based on the density of this visualization? So this is just like a 3D mapping that shows the longitude and latitude and just a way to map it. And we can see that there is a lot of areas, like 10% of it was classified. So 10% of the areas in Gobe was classified as hotspots. So that means that there are a lot of areas that still need, compared to areas that are not hotspots, that still need more facilities to be sited so that it can cover a lot of people in that area. And then healthcare can be more accessible rather than in a long, being sited in a long distance. And this will actually help people too, especially in the grassroots. If there is improved accessibility to health facilities, a lot of things will change and a lot of things will improve. And that's the beauty of geospatial analysis, whereby we can know the location that is without health facilities, and then we can suggest and inference that, okay, if we put an health facility here, we can have a reduction maybe in maternal deaths. So these are all these insights that are very important. And as a geospatial data analyst, this is what you bring to the table when they said, okay, what is the best place to site an health facility? And then we use another analysis tool. So the first one was used kernel density estimation, while the second one is using the Getty's or hotspot analysis. So this also gives more insights to the areas that are more hotspots, to the local government that there's hotspots. So based on this, we discovered that there's only one local government that will know that there's a concentration of health facilities. And then there's one whereby 95% of it is like they are really no or little health facility compared to others. Please remember that this is in comparison with the other local governments. So 9 local governments, and then we have just one that have prominent hotspots. All right, so we have the network analysis. So network analysis is just a way to examine the relationship and connection between spatial features. You know, there are a lot of questions that network analysis answered because we can know the kind of proximity. For example, we can know the area that an health facility covers. So let's use a good example. If there's an health facility where I am, it is likely that that health facility we get people coming from surrounding streets. So I don't know what example. Okay, let's take an example. A popular location. Let's say in Lagos, a popular location in Ikeja. So in Ikeja, if an health facility is sited in a particular street, we know that the neighboring streets will have people coming from there. But in health, it doesn't work like that, since we know that if the nearest health facility is very far, that means that there will be more people coming from neighboring streets just to get access to healthcare. So network analysis kind of helps in terms of accessibility and connectivity in contrast to the health facilities and where they are located. So we can know the network or the reach where there's proximity to the health facility based on. And network analysis has to do with transportation. We normally use it for especially analysis that has to do with transportation, connectivity, and it also helps to really understand where to actually site it in terms of coordination. Where are people going to have the utmost reach? Is it easy to access based on the network analysis? So this is just a basic calculation of the kilometers in degrees, because we'll be converting this and then we'll be making use of the network X graph to compare this. So this is a lot of code, number of nodes, number of edges. So any network analysis, not just in geospatial analysis, they make use of nodes. They make use of of columns like facility names, ownership, just features from your data with your facility geometry. That means the longitude and latitude of the earth facility. And it's just to help with the visualization so you can see the kind of network you have along your earth facilities. So these are metrics that we actually consider when we are doing network analysis. It's a lot of code, but then once we share this, you'll be able to understand it. And then once you run it, you see that it's not really complex as it looks. So we have this. So degree centrality just has to do with how many nearby facilities a place directly connects to. And between centrality has to do like, okay, what facility serves as a bridge? For example, if I'm going to a particular earth facility, do I have another earth facility that is close based on or what earth facility am I going to get to before I get to a particular earth facility? The closeness of it. And then we have the closeness, that's how quick a facility can reach all others. So if an earth facility is sited here, what is the reach of that earth facility? And these are just numerical representation of this. And then when we see the visualization, because it's the visualization that gives us a very good insight of the relationship between a particular earth facility compared to others. So you can see there's a lot of cold spots here and also around here. But the cold spot and hotspot analysis has to do on a local government level. So it's more or less like a cumulative of all the facilities in a particular local government. And we can see the boundaries of the local government. So that means that in some areas, for example, this area, we can see that although there are earth facilities in a particular local government, it doesn't reach the settlement level in terms of the reach. So that's another analysis that we can do. So rather than stopping at the local government boundaries, we can take it a step forward to see the world level boundaries. So in the words, what is the network analysis of the earth facilities around there? And network analysis, as I've said, is usually used majorly in terms of transportation, access to road, and all other stuff, or time-based accessibility. So this is an example of hotspot analysis too. So Voronoi diagrams. So this is just a way to represent network analysis. So this is just a way to see the facility catchment as I've explained. So it's taking a minute to load. So it's just a way to see the catchment of the facilities. Okay, in a particular facility, what are the catchment areas around it? Exactly. So you can see from these boundaries that, okay, this particular earth facility has this area of catchment, has this particular area of catchment, this area of catchment. And we can see that there are some catchments that have more than one earth facilities around them, or the closeness to the nearest earth facilities is high. So that means that the areas that they are going to cover is going to be low compared to others where they have to they cover a lot of areas till they cover a lot of areas till they get to the next earth facilities. So this is another way to understand the distribution, geospatial distribution of the earth facilities, especially in the state. So there are a lot of information that we are missing. I wonder why. So there may be a lot of reasons, because we are not mapping with how do I put it now? We are not using a visual a colorful map as we have with Folium, where we see, okay, can we zoom in? This is a static map. And the reason why I made it static is because we're kind of like exploring the analysis parts. But we can make this interactive where we plot the map, we see the points, and then we can see the streets. We can actually scroll down in and see the streets, the environment, the store, the other features, other points that actually we give more interpretation to where the health facilities are sited. We can say, or in far, which may be incorrect, is that okay, the areas where there are not a lot of health facilities, maybe the area is for farming or for agriculture, or there are not a lot of people there. And that's why this analysis still needs to be done, like layering the population of people in Gombe State on this map to really understand and get better insights on this data. And then we have the accessibility analysis. The accessibility analysis also shows the accessibility between these health facilities. And then the distance to nearest health facility just shows the range, just as I've said, the nearest facility based on the buffer that we have. So for those that are within 6 kilometer, 12 kilometer, 18 kilometer, we can see it here. And this is an example of the catchment facility that we saw the other time. So this is just like a statistics of the health facilities in Gombe State. So we know that there are 897 health facilities. And the maximum distance between one health facility to another health facility is 54. But averagely, the distance is 9.1 kilometers. And then the median distance, at least in Gombe, the median distance are okay. If you get to an health facility, you are at least, the median is that maybe 4.2 kilometers you should see or get another health facility. And then we have the area within 5 kilometers. So there are a lot of 55.7% of health facilities covers an area within 5 kilometers, which is actually good, but could be better. And then we have areas within 10 kilometers. So we have 72.2% covers areas within 10 kilometers. And then we have area within 20 kilometers, which is 84.6, which shows a lot. So this is kind of like an aggregation of the coverage. And then we have the underserved areas that are greater than 10 kilometers from the facilities are 15.4%, and areas that are greater than 10 kilometers from the facility are 27.8%. So I hope that I've been able to explore how Python can be used effectively for spatial data analysis, not just the normal visualization of data, but to actually do a lot of heavy lifting spatial analysis, especially using a statistical tool. And these tools are actually embedded in Python libraries. So I don't know if anyone has any question.
So, all right, since there are no questions, we will, and it's just our time. So we have kept our promise to keep the time. And I know that some of us may still be wondering. So that is why this session is being recorded. And I'm glad to let us know. So I'm glad to let us know that we will be working at it, and lately, early next week, we'll be having it on our YouTube channel, and I'll be posting the link on our pages. So thank you once again, and